everyone, so in this video we're going to talk about some of the most important probability rules, the and the or rule, and we're going to start with the complement rule. So keep in mind, the probability is just the chance that something's going to happen. So how many options you have out of the total, and so the sum of all the probabilities in a sample space, which is all the possible options, has to be exactly 1 or 100%. Everything has to add up to 100%. So with that in mind, here is the complement rule, which is very much common sense. Remember that this little c means the complement of set A, which basically means like everything that's not in A. So let's start with this example actually. This says, what is the probability of drawing a heart from a deck of cards? So in the deck of cards there are 13 hearts out of 52. Basically it's a fourth of them are hearts. So you could simplify that to 1/4 if you wanted to. Okay, now what's the probability of drawing something other than a heart? So basically anything that's not a heart. This is the complement of drawing a heart, not drawing a heart. And since drawing a heart is 1/4, not drawing a heart would be 3/4. It's as simple as that. What you just did in your head though is you basically did 1 minus the 1/4 and you got 3/4. So that's what this rule is saying here. To find the probability of the complement of A, basically just do 1 minus the probability of A happening. Here's another example. Let's imagine the probability of A is 0.73. What would be the probability of not A? Again, just do 1 minus A, and in this case we get 0.27. Because these two have to add up to 1. Or this works backwards. If the complement, remember a little apostrophe also means complement. So if the complement of A, the probability there is 0.42, I want to know the probability of A. Again, just do 1 minus 0.42 and we get 0.58, and that's it, because they add up to 1. All right, we're going to do this in class, but let's imagine we have a class with, I don't know, 20 students, and imagine 5 of you are 15-year-olds and 15 of you are 16-year-olds. If I were to randomly pick someone, so not just like close my eyes and point, but actually like draw a name out of a hat, so like a random sample, what's the probability that person is 16 years old? Well, that would be 15 out of 20. You can simplify that if you want to 3/4. Here's what's new. If I pick 2 names, what's the probability they're both 16? And imagine I'm putting the names back. So I pick a name, I put it back and mix it up, and then I pick another name. Because that does matter. So if I pick 2 names, what do you think we would do here? So actually all you have to do is multiply. If there's a 15 out of 20 chance that the first person's 18, and there's a 16, and a 15 out of 20 chance that the second person is 16, then you literally just multiply them. And that will give you the probability of picking 2 people that are 16. If you want to put a third person in, you just multiply by another one. Like what if I want a 16-year-old, then a 16-year-old, then a 15-year-old? So here's 16, 16, and then multiply by 15, which would be 5 out of 20. So this right here is what we call the multiplication rule, and it has to be for independent events. So as long as events A and B are independent of each other, they don't affect each other in any way, then all you have to do is just multiply their 2 separate probabilities together, and that gives you the probability of A and then B happening. This is on your formula sheet, and again, this only works for independent events. So what I mean by independent events is the occurrence of one does not change the probability of the other. Basically, like, the outcome of one event doesn't affect the outcome of another event. Like rolling a die multiple times. Those are independent events because the first roll doesn't affect the second roll. Or drawing a name and then putting it back and mixing and then drawing another name. those are independent because the first draw doesn't affect the second one. If I had kept the name out of the hat and not replaced it, then they would not be independent, they would be dependent. And we'll get more into that later. Another example is what's the probability of your homework being graded 2 days in a row? So remember, your homework is graded if we roll a 6 on a die. And so rolling a 6, there's one chance out of 6. If we want 2 days, that would just be another 1/6, and we would multiply them. So that would be 1 out of 36. Let's actually put that into a decimal form. 1 divided by 36 is 0.027 repeating. So there's about a 3% chance that your homework would be graded 2 days in a row. Again, these are independent events because our roll on the first day doesn't affect our roll on the second day. All right, let's go back to our 15 and 16-year-olds. And now we're going to get into another rule. So what we were just talking about is basically the AND rule, or the multiplication rule. Now we're going to talk about OR. What happens if there's an OR here? So this time, let's say there's 10 15-year-olds and 8 16-year-olds and 18 total students. I'm just making up numbers. Let's imagine of those 15-year-olds, 3 of them are wearing white shirts, and of the 16-year-olds, 2 of them are wearing white shirts. Okay. So total, that would be 5 people in white shirts. Let's say I want to find the probability of, like, picking somebody random. What's the probability that they are 15 years old or wearing a white shirt? Basically, you just add them, right? So, like, the probability of somebody being 15, well, there were 10 of them out of 18. The probability that somebody's wearing a white shirt, there were 5 of them out of 18. And we just add them up, but here's the problem. I have double counted some people. So these 10 15-year-olds included the 3 who were wearing a white shirt. And this 5 also included the 3 who were wearing a white shirt. So basically, a way I can handle this is just subtract the ones I counted twice. Subtract the 3 who were both 15 and wearing a white shirt. Obviously, there are other ways you could do this. You could just count up these, you could count up like just the 15-year-olds who aren't wearing a white shirt, plus the ones who are. Basically, you could count up the 10 15-year-olds and then the 16-year-olds who are wearing a white shirt, so plus an additional 2 out of 18. And either of these would give you the same thing. What we just talked about is called the addition rule. Basically, if you want to calculate the probability of one event or another event happening, it's basically like their union, like we've talked about before. What you do is you just add the 2 probabilities together. However, if there is any overlap, you have to subtract it. So if there's any intersection, the probability of A and B happening, you have to subtract that because you've double counted it. You counted it twice for A and for B. Here's an example of this. Imagine a student is chosen at random from our class. Well, let's go back to the data we had. What's the probability of choosing a 15-year-old or, so the probability of 15, or a student not wearing a white shirt? So white shirt, but complement to that. Basically, I'm just still going to do the addition rule. So find the probability of being 15 plus the probability of not wearing a white shirt, and then subtract the overlap. So subtract the people who are 15 and they're not wearing a white shirt. Okay, so let's go back and find that. So probability of them being 15 was 10 people out of 18. The probability of not wearing a white shirt, so we had 5 total wearing a white shirt and 18 students, so that means 13 were not wearing white shirts. Then we're going to subtract the overlap. So who was 15 and not wearing a white shirt? We had 3 people who were 15 and they were wearing a white shirt. So that means if we do 10 minus 3, 7 of them were not wearing white shirts. So subtract those 7. And there we go. That would be, let's make that actually a decimal. So this ends up being 16 out of 18. And then if you want to make it a decimal, you don't have to. That would be 0.8 repeating, or about 89%. All right, here's a couple just a little more vague problems here. Let's say the probability of A is this, probability of B is this, probability of their intersection is this. I want to find the probability of A or B. So just follow the formula. Basically do 0.6 plus 0.7. Note that that's going to be over 100%, so I should automatically be suspicious of that. And then I have to subtract their overlap, 0.4. So that is 1.3, so that's 0.9. By the way, if it's helpful for you, you can always draw out a Venn diagram. So let's imagine this is the probability of A and B, and this is their intersection. So 0.4 goes in here. And then if I want the entire A circle to be 0.6, that leaves 0.2 that's just A. So that this total is 0.6. And then this would be 0.3, so that this circle total would be 0.7. And now if I want to know A or B, anything that's in A or in B, basically their union, then just add all this up. 0.2 plus 0.4 plus 0.3 would also give you 0.9. So that's another way you could handle that. All right, this example is a little tricky. So we want to find the probability of A and B. The way we did this in the past is we would just multiply probability of A times the probability of B. But I can't actually do that here. And it's because it didn't tell me whether A and B are independent events. I don't know if they are. So I'm going to have to work this out another way. I can't use the multiplication rule because that only applies to independent events. But I do have actually a lot of information. Remember that the probability of A or B is equal to the probability of A plus the probability of B, and then you subtract the overlap. I can actually use this, fill in everything I have to solve for this right here. Because I know that A or B is 0.95, I know that probability of A is 0.5, B is 0.65, and now I can just solve for this. I'm going to call it X just to make my life a little easier. So just solve it like with normal algebra here. I'm going to do 0.5 plus 0.65, which is 1.15, whoops, minus X. And then subtract 1.15 from both sides. So negative 0.95 minus 1.15. Wait, something weird happened here. Oh, sorry, I made that negative on accident. 0.95 minus 1.15, and we get negative 0.2 equals negative X. To get rid of the negative, just multiply or divide by a negative 1. And so 0.2 equals X. So basically, use that OR rule, use the addition rule to find the probability of A and B. Unless you know that A and B are independent events, then you can just multiply them. All right, here's one other example. Basically where you might have to use some algebra. Remember that this U stands for OR, so I know that A or B is equal to the probability of A plus the probability of B, which I don't know yet, minus the overlap. Remember this symbol here means and, or the intersection. Oops, I didn't mean to do that, just put a 0. So fill in A, B, and A and B, and it equals A or B. So again, you could just solve for probability of B. 0.35 minus 0.2 would be 0.15. subtract 0.15 from both sides, and that will leave us with 0.65 for the probability of B. There we go. Here's another example. Imagine in a certain town, the probability that a person plays a sport is 65%. Like I just pick a person at random and 65% of them play a sport. The probability that they're a teenager is 40%, which feels like a lot of teenagers, but okay. The probability that a person plays a sport and is a teenager is 25%. What's the probability that they play a sport or they're a teenager? So basically combining the people who play sports or the people who play teenagers, we're counting all of them. Again, just follow that formula. So the probability of sport or teenager is the probability you play a sport plus the probability you're a teenager. But then we have to subtract the people who play sports and are teenagers because we double counted them. So the probability of both sport and teen. And it gave us all this. Sport is 65% or 0.65. The probability they're a teenager is 40%. Notice there's definitely some overlap because this is over 1. So we'll subtract the 0.25 that we're playing a sport and a teenager and see what we get. That is 0.8 or 80%. All right, one more example. Assume that the following events are independent. That is key. That means I can use the multiplication rule. So the probability that a high school senior will go to college at this particular school is 0.72. The probability that a high school senior will go to college and live on campus is 0.46. What's the probability just that a high school senior in general will live on campus? This we can use the multiplication rule for because they're independent. So I know that the probability of going to college and living on campus is equal to the probability of going to college times the probability of living on campus, which I'm calling L. Basically just fill in all the pieces. It told me the probability they will go to college is 0.72. I'm trying to find the probability they'll live on campus, so this is what I don't have yet. But I do have the probability they will go to college and live on campus is 0.46, which is this. The word and is important there. And basically just solve for the probability of living on campus by dividing by 0.72 on both sides. And let's see what we get. 0.46 divided by 0.72 is 0.638 repeating. And that's the probability they live on campus, about 64%. All right, what is the probability of choosing a jack or, the word or is important, or a queen from a standard 52 card deck? So if I want to follow the rule here, jack or queen, I would do the probability of drawing a jack plus the probability of drawing a queen, and then I would subtract the overlap. Subtract the probability of drawing a card that is both a jack and a queen. Here's the thing, there is no card that's both a jack and a queen. That is 0. So if these events are mutually exclusive, which means there's no overlap, then you don't have to worry about that last part. You can just add them up as it is. So the probability of a jack, how many jacks are there? 4 out of 52. And then there's 4 queens out of 52. So you would literally just add them up and it would be